Here's LeTeam's presentation on automated stain removal, sponsored by Presso. Design problem is simple. Presso has already created a product that deodorizes and steams garments. LeTeam's job is to create an automated stain detection and removal system. The need for this type of project is crucial, as traditional stain removal is inefficient by requiring manual effort or full washes that waste resources. The need for a targeted, automated solution to enhance efficiency and convenience in industries such as hospitality, dry cleaning, and travel can all see massive benefits of such a product. Backgrounds such as automated stain detection, targeted cleaning, and mechanical removal without the garment being damaged is background necessary for this course project to be completed.
Here is a design overview of our key functions. The first one is cleaning tool movement, where the solution is to create a custom CNC router which provides 3D motion to reach stains across garment without repositioning it. The next is garment securement, which utilizes 4 spring-loaded clamps firmly hold the garment in place to maintain stability and ensure thorough cleaning. Next is detect stain location. A Raspberry Pi camera with K-clustering identifies stain locations and sets coordinates to an Arduino. Then we have liquid dispensing, which uses a set of pumps to deliver one fluid at a time through a manifold and nozzle for precise stain targeting. And lastly, the stain removal tool, which is essentially a motor-driven brush which removes stains with controlled strokes and rotations. On the right is an early prototype design which showcases the core functioning components.
Taking heavy inspiration from the way that in which CNC routers and 3D printers move, LeTeam has designed a low-cost CNC router frame that has both X, Y, and Z movements. All parts are hand-picked to retrofit for fluid application, and a prototype is equipped to clean a collar of a shirt as shown in this picture right here. As mentioned previously, the CNC routing system will use a 3-axis motion system, X, Y, and Z. Constructed out of 2040 aluminum extrusions and 6061 aluminum plates, the stability of the CNC router is crucial as garments need to be locked into place while cleaning. The X-axis is controlled by a ball screw mechanism for reduced friction and smoother movement. The Y-axis is a standard lead screw supported only by the Z-axis. And finally, the Z-axis is an off-the-shelf unit with integrated lead screws with 22mm vertical travel, allowing for the user to insert and take out their garment without touching the brush. Using clamps to spring-loaded blocks as shown right here for garment securing, sponsored by Presso, the shirt is fully stretched, ensuring optimal clean performance. Clamps are positioned both at the back and front of the device to ensure stretch and proper cleaning.
This system is responsible for delivering water and cleaning solution to the target area. It dispenses one fluid at a time using a manifold, ensuring controlled distribution. Peristaltic and diaphragm pumps are used to draw fluid from reservoirs and accurately spray the selected liquid onto the stained area via a nozzle. This nozzle is strategically positioned at the application site, which ensures that direct fluid precisely lands on the stain.
Fluid dispension, the manifold, which is the heart of the system. The manifold consolidates 4 liquids, as shown right here, into one single outlet. The purpose is not for mixing, but to reduce the number of nozzle outputs into one. Current designs accumulate up to 4 liquid intakes and allowing no resistance and no vacuums to be formed using this air inlet. The fluid path is shown below. Using a 16-ounce reservoir, the peristaltic pump draws from these reservoirs and feeds directly into the manifold. The diaphragm pump then takes the single consolidated liquid and applies it onto the stain. Stain removing is done with a spindle motor and brush. Using a DC 12-volt motor, as you can see right here, the spindle motor is mounted to design to move vertically along this Z-axis. The motor drives the brush head, which is coupled right here, which meets the garment, as you can see right here on the ASME logo. Now there's many ranges that this motor can move on, and quite frankly, we don't need that much RPM to clean a garment. So we have 3 types of ranges. Delicate fabrics, which include silk, wool, and thin cotton, goes at 100 to 250 RPM, gently scrubbing and preventing damage. Standard fabrics, cotton, polyester, and blends, goes from 250 to 750 RPM, effectively stain removal without excessive wear. And durable fabrics such as denim, canvas, and workwear uses 750 plus RPM, which is aggressive scrubbing for tough stains. Finally, we can get into the stain detection overview. Utilizing the Raspberry Pi camera, which is shown right here, it is mounted on top of the fluid housing and moves with the system. The camera can be adjusted using these sliders shown right here. At home position, the camera has a wide photo of the garment, particularly focusing on the collared shirt. Now, the hardware behind this stain detection is a Raspberry Pi Zero 2W. Paired with the camera, the resolution is sufficient enough to clearly identify stains from an 18 by 3 inch area. So at 15 inches away, this is perfect optimization for our usage. Finally, the software used is the K-means clustering algorithm. It is used to segment images into strand and not strand areas. In using OpenCV Python library, we'll utilize for implementation. So essentially taking unlabeled data, clustering together, and creating box images around said data allows us to coordinate our CNC router to locations and scrub and clean.